To start us off, we're going to look at stress orientations for sigma 1 and sigma 3 and how to get those from Slickenlines. So there's another video I did on how to get these from Slickensides, but this one we're going to focus on slip lineations. If you have me for structure, this is in Lab 5 and it's task 2. I've changed the numbers a little bit so that we can walk through an example, and then you can just use this to kind of guide you step by step through the lab. So this is the type of question you might get. Slip lineations on fault A are 30 degrees south 20 west. So just to remember what's going on here, a slip lineation is one of the Slickenlines on a Slickenside. And this one is plunging 30 degrees and it's oriented south 20 west. So it's kind of oriented like this. The slip lineations on fault B are dipping 10 degrees, plunging 10 degrees, and they're oriented south 40 east. So south 40 east and dipping 10 degrees. So both of these slip lineations are pretty shallow, and one is oriented to the southwest, one is oriented to the southeast. Faults A and B are a conjugate pair. So if you remember back, failure tends to happen 30 degrees to sigma 1. So if I'm going to imagine having a rock core and I apply a vertical sigma 1, I might have failure that happens 30 degrees to sigma 1 this way, or I could have failure that happens 30 degrees to sigma 1 this way. And when we see those two faults together, we call that a conjugate pair. Usually, a conjugate pair is going to be 60 degrees apart. And the reason for that is that both sides of this pair are 30 degrees from sigma 1. So that side is 30 degrees, and this side is also 30 degrees. It also means that there's a relationship here between those planes and sigma 3. So if I draw in sigma 3 here, if I know that it's 90 degrees between sigma 1 and sigma 3, and this is 30, then I'm going to have 60 degrees from the plane to sigma 3 and 60 degrees from this plane to sigma 3. So a couple of things to notice. One, there's definitely an angular relationship here. Sigma 1 bisects the smaller angle or the acute angle between those two planes. So I'm going to make a note of that. Sigma 1 bisects the small angle between the pair. And I can also make a note that sigma 3 bisects the big angle, or the obtuse angle between the pair. Now, in this situation, it might be kind of hard to imagine where sigma 2 is oriented. And in a way, it's kind of a trick. If sigma 3 is this way and sigma 1 is this way, then sigma 2 is coming out right at you, and it's coming out from the intersection of that conjugate pair. So I'm going to draw kind of the tip of an arrow pointing at us and say sigma 2, just so we kind of remember that that's there also. So let's step through this problem one step at a time. All right, so first, faults A and B are a conjugate pair. What are the orientations of the principal stresses responsible for faulting? What are the orientations of the faults? Okay, so let's get this done. The first thing we're going to do is plot both lineations on a stereonet. each set of lineations is on a different fault plane. We know this. One is on A, one's on B, but both faults formed due to the same stress field, or combinations of sigma 1, 2, and 3. They form together because of the same stresses, and this is what makes them a conjugate pair. So let's plot both lineation sets on the stereonet. Okay. So I have not traced my stereonet. Oh man, I did not come prepared. So now I'm going to go ahead and plot the lineation sets. So I know that the first one I'm going to plot is south 20 west, south 10 west, south 20 west. And I need to come in 30 degrees on that. Let's see, 30-degree plunge. So I rotate my south 20 west over to the east-west axis, and I'm going to count in 30, put my point. And these are the lineations on fault A. So I'm going to call it LA. And then my other set was at south 40 east. So 10, 20, 30, 40. And I need to come in 10 degrees for that one. So I'm going to rotate up to the east-west axis and count over 10 degrees. All right, and I'm going to call this one LB. Those are the lineations on fault B. Each of these sets of lineations is on a different fault plane. So now I need to figure out what is the angular relationship between each stress and the failure plane. Not on here necessarily. I just need to remember and make a note over here. We already kind of drew it. So just to remind ourselves, sigma 1 is usually 30 degrees from the failure plane. It bisects the acute angle between the conjugate pairs. Sigma 3, this one's going to be a little bit easier, is usually 60 degrees from the failure plane, and it bisects the obtuse angle between the conjugate pairs. And sigma 2 is usually in the plane of failure. For normal faults and thrust faults, it lies along strike. Okay, so now my steps are going to be this. I'm going to plot a line that contains both sets of lineations. This line represents a plane containing sigma 1 and sigma 3. Now that's a little hard to visualize, so I'm going to make a little sketch to hopefully help make this a little bit clearer. Let's pretend, and this is not exact for this particular problem, let's pretend that I've got a conjugate pair. A really easy conjugate pair to visualize is a Graben system. Okay, so this is my Graben system. And I've got a Slickenline over here, and I've got a Slickenline over there. Now, I'm probably going to have more than that, but I have one measurement for each. That's fine. What this is saying is that if I have these two Slickenlines that are a conjugate pair, I should be able to put both of those in a plane. Okay, my plane is kind of like slicing across this topography. And the awesome thing about that plane is not just that it contains both sets of lineations, it's that sigma 1, which here would be vertical because it's a normal fault system, and sigma 3, which here would be horizontal because it's a normal fault system, they are also going to be in this plane. If it helps, you can imagine growing this plane out. Growing it across here. And there's your sigma 3, and there's your sigma 1 acting on that plane. Okay, so it kind of cuts this in half. Now, I say that by bisecting the angle between the lineations, we can find the trends and plunges of the sigmas. Okay, so up here, if I could, let's pretend I can take these lineations out. I'm going to draw them right over here. I've got one that's like this. I've got one that's like this. I've just lifted them out of the page, but I'm still looking at them in the plane. Okay, I've just lifted this plane right out of the page and moved it over here. If I bisect this angle, cut it in half, that's going to give me the orientation of sigma 1. As long as I'm bisecting the acute angle. So this angle right here is acute. Either side has the same length. That gives me the orientation of sigma 1. Now, I'm going to imagine these two continuing on going past each other. We don't know that they do, but I'm going to just imagine that. The bisector between the obtuse angle is the orientation of sigma 3. Okay, so in the direction, we're going to know that sigma 1 bisects the acute angle and sigma 3 bisects the obtuse angle. We're going to find the trends and plunges of those angles. Okay, so let's fit both of these to a plane. And I'm going to do this in green just so that it's clear that it's matching up with our green plane on the example that I just did. So if that wasn't totally clear, this green arc represents the plane that we had right here. Okay, now leaving this where it is, just because I think it's easier to bisect angles this way, I am going to count these angles and go ahead and bisect them. So here, the angle between this lineation and this lineation is going to be, I'm just going to count around the circle. Let's see, 8, 18, 28, 38, 48, 58, 59. So this angle is 59 degrees. And then this one, we can't just count this way. We're going to have to count this way too, and that's just fine. Over here, if this is, if that's 59, we're going to do 1, 11, 21. So I've got 21 over here. And then going this way, 2, 12, 22, 32, 42, 52, 62, 72, 82, 92, 102. And then I am going to double check to make sure that that adds up, because I think I overcounted by 2 somewhere on here. Let's see, 8. Nope, that one makes sense. Oh, up here. This should be 19. Another way to double check yourself is to make sure that these add to 180 degrees. You've gone all the way around the bowl, it should add to 180. Okay, so let's bisect these angles then. This one, if I bisect 59, then 59 divided by 2 is 25 plus 4.5 is 29.5. So I'm going to go up close to 30 degrees. 10, 20, that would be 30. We're right below 30 degrees. Put it right there. That bisects the acute angle. So I'm going to label this as sigma 1. Okay, now I'm going to bisect my obtuse angle. And I've got to remember to add those pieces together. So I've got 102, and then it goes over, it keeps wrapping over here. 102 plus 19 gives me 121. 121 divided by 2 is 60.5. So I'm going to start here and go 60 over. So that's 10, 20, 30, 40, 50, 60, 60.5. And this one is bisecting my obtuse angle. That is 63. Or sorry, sigma 3. Alrighty. So now I've got sigma 1 and I've got sigma 3, and I can write down what those are. So to get to sigma 1, I'm going to bring sigma 1 over to the east-west axis, and I'm going to get its plunge. So here that's 10, 20, 22, 24. So sigma 1 has a plunge of 24. And now I need my trend. I need my orientation. So I'm going to mark this axis, spin back to north, and I'm going to count over to where I have sigma 1. And I do everything in azimuthal notation because otherwise I get annoyed. So that's 90, 100, 110, 120, 130, 140, 150, 160, 166. So that's my trend and plunge of sigma 1. Now let's do it for sigma 3. I'm going to rotate it to the east-west axis and count over. My plunge here is 19. And I put a big tick mark so I remember where sigma 3 is. Rotate back to north. And this is 270, so this is 268, 267. So sigma 3 is at 267 for the trend. And for the plunge, 19. Okay. So I can come over now to my answer sheet and I'm going to write these in. Sigma 1 is plunging 24, trending 166. Sigma 3 is plunging 19, trending 267. Good. And I'm going to the next stage. This says that the three sigmas are always 90 degrees to each other. Plot the pole to the plane in C to find the trend and plunge of sigma 2. So if I go back to my sketch, I had thought earlier about the sigma 2 coming right out at me. Same thing here. So the pole to this plane, the pole that's 90 degrees to this plane, is my sigma 2. And to get that, I'm just going to do it like I normally would do a pole to a plane. I rotate my plane to the north-south axis, and going along the east-west axis, I count over 90. 10, 20, 30, 40, 50, 60, 70, 80, 90. And that is sigma 2. Now I'm going to go ahead and mark this, and I'm going to go ahead and count my plunge. 10, 20, 30, 40, 50, 59. And note that I'm going to be plunging 59 degrees, and my trend is 10, 20, 30, 31. So my trend is 031, and my plunge is 59. Oh no! I wrote this in the wrong blank. Sorry, y'all. Trend and plunge 031. 59. Okay. Now, you always know that lineations are in the fault planes, and you also know that sigma 2 is in the fault plane. So now we can plot the fault planes on our stereonet. What that means is that this lineation that I have for LA and sigma 2, those are both going to be in the fault plane. And this lineation and sigma 2 are also going to be in their own fault plane. So I'm going to just pay attention to sigma 2 and LB first. And I'm going to get them on one arc. Good. And this is going to be fault plane B. And now I'm going to do the same thing to get fault plane A. So sigma 2 and A, they've got to be on one fault plane. And in this case, it is nearly vertical. Holy smokes. Yeah. Very steep fault plane. But that's what I get for making up numbers. And that's plane B. Or sorry, plane A. All right. So now I can read off the strike and dip of these planes. So let's do plane A first. Plane A has a strike of 10, 20, 24, 024. And to get the dip, I'm going to rotate that strike up to the north-south plane and count in. And that's 80, 85. It's got a dip of 85. And remember, you should record a direction. That's It's 85 that way. It's 85 to the southeast. Even if you use the right-hand rule, just do yourself a favor and write down that direction. And this fault plane is, let's see, striking 270, 280, 290, 300, 310, 320, 326 with a dip, 10, 20, 30, 40, 50, 60, 61, a dip of 61 to the northeast. Okay, so now I can transfer my answers onto my answer sheet. For fault plane A, that was 0, 2, 4, 85 southeast. For fault plane B, that was 326, 61 northeast. So we've got a pretty steep plane dipping to the northeast and a super steep plane dipping to the southeast. So that's my conjugate pair right there. And that's okay. That's cool. Alrighty. Thank y'all and good luck with lab.